Sometimes, sets can feel abstract. When you're working with lists, symbols, or expressions like A intersection B or a union B, it can be hard to grasp the relationships. That's where Venn diagrams become powerful. Introduced by the English logician John Venn, these diagrams give us a visual way to understand set relationships. They let us see how sets combine, overlap, or differ, which makes abstract concepts easier to understand. Here's how a Venn diagram is set up. The universal set, usually denoted by the letter U, is drawn as a large rectangle. Inside this rectangle, each set we are studying, for example, set A or set B, is shown as a circle. Every element that belongs to a set is placed inside its corresponding circle. If an element belongs to both sets, it is placed in the overlapping region of the circles. Let's take a basic example. Suppose the universal set U is the set containing numbers from 1 to 10. Set A is the set of even numbers, brace 2, 4, 6, 8, and 10, close brace. In the Venn diagram, you draw a circle labeled A inside the rectangle for U. All even numbers are placed inside the circle. The remaining numbers 1, 3, 5, 7, and 9 are placed outside the circle A, but still inside the rectangle U. Now, let's add another set. Let set B be the set containing 4 and 6. These elements already appear in set A. So, the circle for set B will partially overlap with circle A. The overlapping area shows the intersection, the elements that are common to both A and B. Elements that are only in A or only in B will lie in the non-overlapping regions of their circles. This example helps us see how union, intersection, and difference work visually. Venn diagrams are incredibly helpful because they allow us to quickly identify whether two sets are disjoint or overlapping, clearly visualize operations like A intersection B, which shows common elements, understand a union B, which includes all elements from both sets, recognize the complement of A, which means all elements in the universal set that are not in A, handle multiple sets in more complex situations, especially in subjects like logic, statistics, and computer science. As we head into the next section, operations on sets, you'll find Venn diagrams even more useful. They help us understand what happens when sets combine, overlap, or exclude one another. Rather than relying only on formulas or symbolic notation, you can see the result directly, so keep your visual thinking sharp. Because Venn diagrams are your essential toolkit for understanding how sets interact.